Hello students, myself Udipta teaching mathematics in Birpara College of Alipurduar district. Today my lesson is on relation for the second semester students of program course. So let's quickly begin our discussion. To understand this topic, you must have a strong base in set theory and in Cartesian product of two sets. At first, we will see what is the Cartesian product of two non-empty sets. Suppose there are two non-empty sets, capital A and capital B, where the set capital A contains two elements, 1 and 2, and the second set capital B contains another two elements, small a and small b. Then the Cartesian product of these two sets, capital A and capital B, is denoted by A cross B, and the elements in this set, that is in A cross B, are in the form of some ordered pairs, and these ordered pairs are 1, A, 1, B, 2, A and 2, B. That is, there are all total 4 ordered pairs in A cross B, and these pairs are called the ordered pairs as they have maintained some specific order. The order is that in each ordered pair, the first element, that is 1 and 2, comes from the first set A, and the second element in each ordered pair, that is A, B, belongs to the second set capital B. And one more thing is that if a set capital A contains P number of elements and the second set capital B contains Q number of elements, then the Cartesian product of these two sets, that is A cross B, will contain P into Q number of elements. In our example, we have seen that the Cartesian product of those two sets A and B contains 4 ordered pairs such as 1A, 1B, 2A and 2B, because the set A contained two elements 1 and 2, and the second set B also contained another two elements A and B. So this is the main concept of Cartesian product of two sets. So now we are in a position to understand that our main topic, that is relation. In mathematics, relation is nothing but our day-to-day relationship in our daily life. Let's take a real life example to understand this topic more clearly. Suppose I have a family and I have divided my family in two groups, group A and group B. And in group A there are 4 members, father, uncle, grandfather and brother. And in the second group, that is group B, there are 5 members, that is mother, aunt, grandmother, sister-in-law and sister. Now if we take Cartesian product between these two sets, that is group A and group B, then what we will get? Let's see. Then the Cartesian product of these two sets, that is A cross B, will contain total 4 into 5, that is 20 ordered pairs according to the earlier result. So the all possible ordered pairs belongs to this set are the followings, and they are father mother, father aunt, father grandmother, father sister-in-law and father sister. And likewise with uncle, we will get another 5 ordered pairs such as uncle mother, uncle aunt, uncle grandma, uncle sister-in-law, uncle sister. Similarly, with grandfather, we will get another 5 ordered pairs, and they are grandfather mother, grandfather aunt, grandfather grandmother, grandfather sister-in-law, grandfather and sister. And similarly with brother, we will get another 5 ordered pairs, that is brother mother, brother aunt, brother grandma, brother sister-in-law, brother sister. So now I am defining a relation capital R between these two groups of members, that is between group A and group B. And the relation is R equal to ordered pair XY, where X is husband of Y, and X belongs to the first group A and Y belongs to the second group B. Then in this relation we will get some ordered pairs, and they are father mother. Since father is a husband of mother, again the ordered pair grandfather grandmother, because grandfather is husband of grandmother, and uncle aunt, and similarly brother and sister-in-law. So if you observe that each of these ordered pairs, that is father mother, grandfather grandmother, brother sister-in-law and uncle aunt, all of them are also belong to the Cartesian product of those two sets. So that is, the set of all ordered pairs in capital R are the subset of A cross B. So that's my point, what I want to deliver, that relation between two sets A and B is nothing but the subset of Cartesian product of those two sets, that is A and B. So relation R is a subset of A cross B. Now we will see some more things, that is what is domain of relation, what is range of relation, and what is codomain of relation. So at first we will discuss what is domain of relation. So remember, domain of a relation is the set of all first elements in each ordered pairs belongs to that relation. In our example, in the relation R, there are 4 ordered pairs, that is father mother, grandfather grandmother, uncle aunt and brother sister-in-law. So the first elements in these ordered pairs were father, uncle, grandfather and brother. So the domain of this relation R will consist 4 members, that is father, uncle, grandfather and brother. And the second set where the relationship has been built up, that is the set capital B, is called the codomain of the relation R. Now we will see what is the range of the relation. So remember, the members of the codomain who are in a relationship with the members of the first group will consist the range of the relation R. In our example, in the second set, that is in codomain B, the mother is wife of father, aunt is wife of uncle, and grandma is wife of grandfather, and sister-in-law is wife of brother. So the range of the relation R will consist 4 members, that is mother, aunt, grandmother and sister-in-law. And notice that one more member, that is sister, in the codomain were not in a relationship with anyone in the first group. That is, we may conclude that the range of the relation R is a subset of codomain. It may happen that range of the relation is equal to the codomain. Okay. So in this discussion, we have seen two different representations of relation R. In the first form, we have stated the relation in the form of ordered pair XY, where X is husband of Y, X belongs to A and Y belongs to B, is called the set builder form of the relation R. And in the second form of relation, that is the relation R which contains ordered pairs, is called the roster form or tabular form of the relation. And one more question may arise from this discussion, that how many relations can be defined between the sets A and B. So remember, if the first set capital A contains P number of elements and the second set capital B contains Q number of elements, then total 2 to the power PQ relations can be defined between these two non-empty sets A and B. And in our example, the group A constitutes 4 members, that is father, uncle, grandfather and brother, and the second group consists 5 members, that is mother, aunt, grandmother, sister-in-law and sister. So between these two sets A and B, there 2 to the power 4 into 5, that is 2 to the power 20 relations can be possible to define. So in our next lecture, we will see different types of relations, that is empty relation, universal relation, reflexive relation, symmetric relation, transitive relation, antisymmetric relation, and finally equivalence relation. Okay, thank you.
This and other episodes of Radio EduPod's Radio for Learning are available on Listen to My Radio app at 6 p.m. from Monday to Friday and at 6 a.m. from Tuesday to Saturday. All episodes are available on Salesian TV YouTube channel. Share, like and subscribe Salesian TV, the ultimate learning resource channel.